This is lesson 4.4. It's about factoring quadratic expressions. And in this lesson, we'll learn how to factor trinomials where a is 1. And we'll also learn how to factor out a GCF, or a greatest common factor. And then finally, we'll learn how to factor a perfect square binomial. So here are 3 examples of factoring a trinomial. So one method that you can use for factoring to organize your thoughts is to draw this giant X. You take your C value and put it in the top. Your B value, without the variable, goes in the bottom. And then you ask yourself, what are 2 numbers that multiply to make 20 at the top, and they add to make 9 at the bottom? So those 2 numbers would be 4 and 5, because 4 times 5 multiplies to make 20, and 4 plus 5 adds to make 9. So these are the values that we would use in our factoring. So we have x plus 4 and x plus 5. If we were to do the same thing for example B, the number on top would be negative 72, because the negative goes with the number, and positive 14. So we need 2 numbers that multiply to make negative 72, and they add to make 14. So 2 numbers that multiply to make 72 and add to make 14 would be 4 and 18. We want this to come out to a positive 14. So if 4 is negative, negative 4 plus 18 is positive 14. But negative 4 times positive 18 is negative 72, so that's going to work out. And then we can factor it as x minus 4 and x plus 18. If you're not sure what numbers to use, you should make a list for 72. So 1 times 72, 2 times 36, 3 times 24, 4 times 18, and 8 times 9. Once you have your list, from the list you pick the ones that are going to be able to add to make the 14. Okay, our last example here, we have a coefficient on the front here of negative 1. It is never pleasant to try to factor with a negative as your leading coefficient. So what we would do here is first factor out the negative 1, forcing the x squared to be positive. But if we factor out a negative 1 from 13, we get negative 13. And factoring out negative 1 from 12, we get positive 12. Then we can factor with positive 12 and negative 13. So that would be negative 12 times negative 1 is positive 12, but that adds up to make negative 13. The negative 1 is part of our answer, and our factors are x minus 12 and x minus 1. You do not have to write the 1 on the front here. You can just leave it as a negative, so this would work as well. Sometimes you will see problems like these where there is a common factor in your terms. So if you have a common factor, you want to factor it out. And in this case, 3 goes into 6 and 9, but we also have an n squared and an n, so we can divide out n. So dividing 6n squared by 3n gives us 2n, and dividing 9n by 3n gives us 3, so this would be factoring out our GCF. On the second example, our GCF is just 4 with no common variable. So if we factor out 4, we get x squared plus 5x minus 14, like so. Okay, the final thing I wanted to show you is how to factor a difference of 2 squares. This is a difference because there's subtraction in the middle, 2 squares because our first number is a perfect square and our last number is a perfect square. So to factor this, you take the square root of 25, which is 5, with just 1x. The square root of 49 is 7, and both factors will be similar. But in order to make a negative 49, we have to have one positive 7 and one negative 7. So then when we FOIL this, we'll get 25x squared minus 35x plus 35x minus 49. So the middle part of this cancels out, and that's how we end up with just two terms, 25x squared minus 49. So the second one will factor as 4x minus 9 and 4x plus 9.